Hi everyone, my name is Toma Puljak, and today I'll talk about how browser IDs are enabling the transition of development to the cloud. I'm sorry if I sound a bit weird, I'm a bit sick today, but I think I'll power through the presentation. In the first part of my talk, I'll talk about actually what the transition of development to the cloud brings to developers and the new development workflow that entails this kind of system. And in the second half of my talk, I'll talk about the browser ID specific features that are enabling this kind of transition and that basically ease up the whole process. So a bit about myself. I'm a software developer at Codeanywhere. I'm 22 years old. I've been a programmer or a software engineer for the past, I think, 6 years. And I'm currently focusing on business-to-business integrations and, of course, ID customizations. I've been developing Theia extensions for the past 4 years, and I love actually giving talks at conferences. And this is my first actual virtual talk at a conference. So a bit more about Codeanywhere. We're basically a 11-year-old company. Actually, our founders 11 years ago found the need for developers to access their code really quickly, and they envisioned this idea of you moving your entire development to the cloud. So they basically created their own browser-based ID. But through the whole process, they actually decided to adopt Theia as the browser-based editor, and actually their vision of moving the development process to the cloud is now taking effect and is seen in the mainstream with a lot of different products on the market offering cloud-based development. So I'll start by taking a look at the usual development process and onboarding process. With local development, I like to call this process the usual. So it's basically step 1, clone the project, nothing exciting here. At step 2, set up an ID that you'll use to actually code the project in. Step 3 is open up the README file, runbook, documentation, anything you need to help you set up the project. Step 4 is start executing some installation scripts, start reading through some steps. And step 5 is basically the script or the installation might fail for some reason. And any reason could be, so basically your OS isn't updated, maybe you have the wrong language runtime, or the script is simply outdated, because I know we all sometimes forget what we install locally, and then that doesn't end up committed into the project. So step 6 is you try to fix it manually. So basically you update your OS, you install the right runtime. For example, you need Java 18, but you were on Java 11, so you now upgrade to Java 18. And you add what's missing in the script because you know your way around that kind of installation, but it still doesn't work. And you're kind of getting frustrated right now, and you move on to step 7, which is basically a cry for help. You ask a colleague for help, you bother them, you move them away from their work, because of course they set up the project on their machine, they should be able to set it up on yours, on your laptop, your computer, your whatever, basically. And then you move on to step 8, which is but it works on my machine. So basically the colleague doesn't know how to set up the project. They don't know what doesn't work on your machine, and they just say the feared phrase, but it works on my machine, and leave you to fight the battle on your own. So nothing left to do here but flip your table, go back home, and try again tomorrow. So a few days of this pass where you're not really coding efficiently because you can't set up the entire project on your own, and somehow the setup magically succeeds after a couple of days, and you can actually start coding. So you can actually see how this entire process can lead to a lot of frustration, not only in yourself, but in the colleagues that you're bothering for help. And you can see that this is wasting resources because, of course, our time is actually very valuable as developers, and it's valuable to the company. And you wasting time on this kind of setup process is really inefficient, and it's just wasting resources. And of course, this is not a one-time thing. This kind of setup needs to happen every time you move from a project to project. That can be on a weekly basis, monthly basis, daily basis, or you just want to contribute to open source code or help out a colleague. This entire process needs to be done every time you start up a project or a feature or something like that. So fear not, the end of localhost is here. And basically, I don't mean localhost as a network. You'll still be using localhost. But the idea of the end of localhost is that you move your development from local to the cloud, basically. And with localhost, the end of localhost actually brings you not worrying about environment setup, not worrying if your machine can handle the project load. If a project is really resource intensive and demanding, when the actual project is not hosted locally, you don't have to worry about if your machine can handle the load. And you don't have to worry about security. You can have these cloud-based environments running inside your fully secure infrastructure, inside the company, in tightly sealed, and security shouldn't be an issue in these kinds of development flows. So the end of localhost actually entails a new way of thinking, and this new way of thinking is very important for adopting this whole concept. And this new way of thinking basically defines the new, and the new is this new development process, this new fresh perspective on development, which will basically solve the problem I introduced before. And step one of that new way of development is click a button, and step two is start coding. So again, it's step one, click a button, and step two, start coding. So I'll show you a demo video of this right now, and you'll see that the actual demo of this kind of setup takes less time than actually talking about the entire usual process I talked about before. So you can see here I'm in GitHub. I just click one button that will take me to Codeanywhere in this case, which will start building everything our project needs to be able to run. Once the environment is built, we're instantly transported to a browser-based IDE. In this instance, it's actually Theia with Codeanywhere branding in this instance. And basically, a file you're meant to see for the first time actually opens right away. And you can actually start coding instantly when you're inside the IDE. So it was step one, clicking that button, and it's step two, actually starting coding right away. So I'll briefly talk about how to make all of this possible and what actually cloud development is behind the scenes. So let's take a look again at the usual Git process, or basically the Git workflow when working on projects. So let's say, for example, we're on the main branch running Java 11 in this case, and we need to upgrade to Java 18, for example. So we check out our feature branch 1, we upgrade to Java 18 locally, and we start migrating the code. And because the main branch moves on, we see an issue on the main branch we need to address. So what we need to do, we need to actually check out feature branch 2 on Java 11, and now we have to downgrade our machine Java version to Java 11 to actually be able to work on the old code or the main code, basically. And then when we're done with feature branch 2, we actually move again to Java 18, and we again have to go through the exact same setup process to migrate from Java 11 to Java 18. And it's not the only problem that you have to upgrade from Java 18 to 11 and back and forth. The problem is that all of your colleagues have to do the same thing if they're helping you out with these transition and branches. And their machine, again, is not different from yours, and they have to, again, be careful how they migrate their system from version to version. And to solve this, I'll introduce ephemeral development environments, specifically ephemeral cloud-based development environments. And ephemeral development environments are basically environments that are short-lived. Ephemeral just means something that lasts for a very short time. And in the case of development environments, it's basically spin up a development environment when you need to code, when you need to work on a feature of a project. When you're done, you just toss the environment and release all its resources. The idea of this is that this process can be repeated any number of times, and it's guaranteed to work every single time. And this process is not actually reserved only for development. This process is actually, let's say, stems from DevOps, because DevOps use ephemeral development environments on a daily basis. For example, you having an environment that tests your code on a pull request, that environment is basically ephemeral. It tests your code and then it destroys itself, and that's it. That's an ephemeral development environment. So if we apply ephemeral development environments to our previous example, when we want to work on the feature branch 1 environment, we just upgrade our system locally to Java 18. But then when we need to move back to feature branch 2, we need to destroy the environment and start from scratch again. And this kind of process will allow us to end up in exactly the same configuration every time. And apologies for this. So this kind of process where you destroy your environment and start installing the environment components from scratch will guarantee that you and all your colleagues will have the exact same environment setup. So this, of course, is not feasible in and of itself, you destroying your environment, installing everything manually each time you want to check out a branch. So this is where environment configuration comes into play and some of the tools that help out in this whole ephemeral process, basically. So configuration is based on another DevOps concept called infrastructure as code. And basically, infrastructure as code, or IAC, is just provisioning and managing infrastructure resources through code rather than just clicking buttons on a UI. And this concept can be translated into development environments as well. And companies and products are already doing it. For example, Docker with Dockerfile, Coder with Terraform, Gitpod with their proprietary gitpod.yaml file, and Codespaces and Codeanywhere implementing dev containers. And basically, all of these configuration standards are actually infrastructure as code translated into development environments, because all of these files and standards serve as your, let's say, explicit configuration for your project to spin up a development environment. Apologies again. So let's focus now on dev containers and why we actually decided to adopt dev containers. And dev containers are actually Microsoft's open source standard for development environments, development containers, basically. And they look something like this. So this is some example of a dev container JSON file for some Rust example. So basically, there are a couple of components here I'd like you to focus on. First is the Docker Compose file, which just points to a Docker Compose file inside the dev container configuration folder. And the other thing I want you to focus on are the features. And features basically allow you to create some modular components for your project configurations, which you can actually use project to project. So for example, we have two features here. One, some common utilities to install ZSH in our environment and set the username for a user. And the other is the Rust feature, which will actually download the Rust language into our development container, and also some additional things like IDE extensions and things like that. And features basically are one of the coolest features of dev containers, I think, and they're basically only just installation scripts. So features can be published on GitHub, for example, and then you just point to their URL. Dev container CLI then basically just runs the installation script on top of your Docker container configuration, and you end up with a modular part of the development environment already inside and installed when you needed to be, and they're ready to work actually really, really quickly. So dev containers aren't actually just for development environment configuration. I mentioned briefly that you can actually install extensions, and you can actually, dev containers can also provide with a configuration for your IDE as well, which is, again, really important if you want this kind of setup running on any machine. So in this example, this is a dev container example for some Python project. And you can see here the settings block of the dev container JSON configuration, where you can see basically the preferences that will be injected into an IDE. In this case, dev containers actually support natively development on VS Code and GitHub Codespaces, but at Codeanywhere, we basically take these settings and then inject them into Theia as well. And then you end up basically with settings committed into your project and translated into Theia settings and put inside Theia. So everyone that basically clones the project and works on the project will have these settings enabled as well. So now I want to talk about how our browser IDE is pushing this whole initiative forward. And in addition to the dev container JSON containing some preferences for the IDE, what the IDE itself can do to make this kind of setup really accessible and really and really accessible to a lot of developers and really efficient in all of the workflows. So apologies. So at Codeanywhere, we actually decided to start off with Theia as our base browser-based IDE, because we found Theia to be very extensible and really easy to work with. And we've been working on Theia extensions for the past 4 years and adapting them to our needs and to the needs of our product. And we believe that even though VS Code and Microsoft is pushing this VS Code initiative to the web, I think that Theia can be a front runner in this cloud browser-based IDE space, because it's so extensible, because it's so easy to work with, basically. So the thing we did to enable this kind of workflow and to make it really easy and efficient to work with is collaboration. We basically made an extension or a couple of extensions to really enhance the collaboration aspect of Theia and of these browser-based, cloud-based development workflows. And this basically means we made collaborative editors, terminals, text chat, screen sharing, and so on. And I'll basically present the concepts behind it, how it works, and what we found out in the process of making these features. So collaborative editors, to start with, basically allow you to, in real time, have multiple users connected to the same session and basically collaborate on code in real time in the same cloud-based development environment. So as you can see here, we have multiple clients. One on the left is user 1, for example, and one on the right is user 2. And you can see that when user 1 is typing, it's immediately in real time displayed to user 2. You can actually track the cursor of each of the users. You can see with the text decoration that we can apply text selection decorations. And of course, we have multi-cursor support as well, where you can have user running actually editing files with multiple cursors, and that will all sync in real time as well with the other connected clients. This, of course, is the core of our collaboration features. Collaborative text editors are something that's becoming a given these days, and something that's a real requirement, because it really makes for a more efficient workflow where you don't have to comment on a PR every time you want to collaborate. You can just invite someone to your coding session, and they can in real time collaborate on your code, basically on your files. To complement this, we basically created a sidebar extension, or basically a sidebar widget, where you can inspect where each of the users are, on which files they're currently located, and you can actually track their cursors. So you can click on a button, and then actually Theia will follow along the other user you're tracking through files and through scrolling and anything like that. So this basically sidebar widget is supposed to be your collaboration hub to interact with other users. Another feature, so collaborative editors are made possible by an open source library called YJS. If you haven't heard about YJS, I strongly suggest you check it out on GitHub. It's really an amazing, powerful tool for basically any collaborative object that you can think of. And in this case, we use YJS for real-time updates, conflict resolution, where you have two users actually editing the same line of code, for example. You need to be able to handle conflicts between those clients. We handle cursor locations with YJS, and we handle text chat as well. And the way it works basically is we have the Theia backend and frontend connected with via WebSocket, basically. On the backend, we have a WebSocket server that's running as an extension, of course, and on the front end, a YJS client connected to that backend. And this way, you can basically have a solution that's, let's say, infinitely scalable, because each client on the front end just maintains one connection to the WebSocket server. Whereas even though YJS supports peer-to-peer network configurations, we found that WebSocket is far more scalable, because a peer-to-peer network configuration, of course, does it have its limits to how many clients can connect. Continuing with our collaborative features, we go to collaborative terminals, and basically the idea here is that one of the users spins up a collaborative terminal This terminal then opens up to all of the clients that are connected to the session, and in real time, again, it's outputted to each of the connected users. And with collaborative terminals, one thing that was, let's say, challenging was how to handle terminal dimensions. And then we decided basically that the owner or the person who started the collaboration terminal will, let's say, win with their terminal dimensions. But basically, collaborative terminals are just propagating their output via WebSocket, again, via Theia's WebSocket protocol to all of the connected clients, and then input-output is handled within the same process running in the backend of Theia. So text chat, again, is one of the features that is really here to help out if you need to quickly comment on some code. It's just a sidebar widget that renders messages that are coming on to a YJS array. So I mentioned before that YJS can handle basically any collaborative objects. In this case, this is a collaborative array that you can push to, and it basically propagates changes onto all of the users. This way you can see, actually, you can have a typing indicator as well, and you can render all of the messages coming onto the array basically synchronously. Another feature that was most, let's say, requested with our collaboration suite is collaborative debugging. And because collaborative debugging is, let's say, one of the hardest collaborative features to develop, we actually decided to go for screen sharing, because screen sharing, again, is more versatile. So you can actually share your screen right inside Theia. Just click a button, and then the connected clients will get a message that another user is sharing. You can actually view the screen share right inside Theia as basically an editor widget where you can inspect what the other user is sharing. This way, we want to allow users to basically share any content and collaborate on any content within the IDE. Audio and video chat is unfortunately not yet available on our platform. Currently, it's on our roadmap, but we're going to implement it really soon. Another collaborative feature, or basically a collaboration feature that is important but not part of the collaboration extension, is port previewing. And port previewing basically allows you to preview any port running inside your cloud-based development environment by just clicking a button that says preview, and you basically get a URL that will take you to the port that's running inside your cloud-based environment. And this allows you to quickly basically preview any running process. You can send this to a client, to a colleague, and they can quickly preview what you're working on inside the actual cloud-based development environment. So with all of these collaboration features, and with configuration standard like Dev Container, we as Codeanywhere believe that the transition of development from local to the cloud is happening really fast. And we believe that having a standardized configuration in your project will allow all of the developers, any open source contributors, to really efficiently start coding right away and not having to deal with any of the fuss along the way. This, of course, fixes the "but it works on my machine" problem. This kind of setup works on any machine. The IDE itself that's working in the browser works on any machine, and that's the whole concept with the end of localhost. So basically, this is the next step in the software development evolution. And we believe that the end of localhost means you never have to install anything locally again. You can actually just run the development environment and be efficient in your workflow. And that means that developers can actually be developers. Right now, no installations, just focus on coding. And basically, what I want you to remember from this talk is step 1, click a button, and it's step 2, start coding. Thank you. Okay, so are there any features in Theia that make your jobs easier at Codeanywhere? So collaboration, for one, is a feature that makes our jobs easier, because you can just send over the link to your cloud-based development environment, and you can just collaborate in real time. Just pop into a collaboration session, pop out when you need to. So that feature is, I think, one of the biggest, let's say, the biggest feature that makes our jobs more efficient. And how big are these dev NFS you build in terms of tools? GB, do you keep it in one container? So the way dev containers work is you can provide a Docker Compose file, for example. You can have then multiple containers running inside the development environment. In Codeanywhere's case specifically, we basically create a container inside Kubernetes currently, and inside that container we run a micro VM, and inside the micro VM we run your development containers. So you can have multiple containers, you can have one container. It basically is up to you, and they can be as big as you want. The idea of this solution is that you can actually self-host it as well. So this solution can be as big as you want it to be. The environments can basically grow as much as your cloud grows. Now that we have development, debugging, etc., can you suggest a cool workflow for collaborative code review? So for collaborative code review, actually, it would be cool if, and that's something that we should be we will be working on, is that you can just create a development environment from a pull request on demand, and then the code reviewer can just jump into the development environment for that pull request really quickly, check out all the code, what needs to be done, and then invite additional people along that need to be there for the code review. So what are the efforts to prepare an environment? The efforts are basically create the dev container JSON file, containerize your application, or basically not containerize the application, but create a dev container container configuration where you can then spin up that dev container configuration in the cloud. So I have to wrap up. I'll be in the event for a few minutes, or basically throughout the whole day. So I'll answer most of your questions via the text chat further. So thank you for being here, and have a good day.